Hey everyone, and welcome to today's Explainer. We're doing something a little totally different today. We're turning our attention to this absolutely fascinating, totally hidden battlefield that exists right behind your walls and literally right beneath your feet. We're going to use Penn Hills, Pennsylvania as a case study to explore how local geography and aging infrastructure are just locked in this silent, continuous battle. It's a clash of physics, chemistry, and municipal codes, and honestly, it dictates the very survival of our homes. Okay. Let's dive into this. What does local geography actually have to do with your toilet backing up? It's a pretty weird question, right? But it's the exact hook we need to really understand this topic. Because, when we think of plumbing, we usually just picture pipes and wrenches. We almost never think about the dirt outside our homes, or weather patterns, or river watersheds. But as we're about to see, nature is the ultimate architect, and frankly, the ultimate adversary of your household infrastructure. So here is our roadmap for today. We're going to cover 1. Penn Hills plumbing geography, 2. The usual suspects, 3. The physics of plumbing, 4. The 3-step rescue, and finally 5. Costs and hidden dangers.
All right, jumping right into Section 1, Penn Hills plumbing geography. So from November all the way through March, this specific region gets hammered by a brutal freeze-thaw cycle. Just imagine the temperature swinging wildly from the teens one day up to the 50s the next. What does that do? Well, everything expands and then it contracts. This constant flexing stresses your pipes until inevitably the joints fail and the fittings crack. Add to that the hilly terrain, which causes massive erratic pressure fluctuations in the water supply. Then, you surround all those buried pipes with clay-heavy soil that physically shifts with the weather, causing your whole foundation to settle. Finally, pump hard municipal water from the Allegheny River watershed, which is just packed with calcium through those already stressed pipes. It's literally a perfect storm of environmental stress.
And how that geography actually attacks your home? That depends entirely on your neighborhood. Take a look at the older areas like Rosedale and Duff. These homes were built back in the 1940s and 50s, so they rely on their original clay sewer laterals. Every single spring, thirsty tree roots seek out the moisture in that shifting clay soil, invade the tiny cracks in those old pipes, and just create massive blockages. Now, on the flip side, look at Universal and Blackridge. These are slightly newer 1960s and 70s homes built higher up on the hillsides. They don't really have the clay pipe issue, but their higher elevation means drastic water pressure fluctuations. That stresses their copper supply lines, eventually creating these tiny but completely disastrous pinhole leaks.
Moving on to Section 2, the usual suspects.
Now, what's really interesting about this slide is the inevitable chain reaction that happens here. These aren't just random isolated incidents, they're direct cause and effect pipelines that turn everyday natural elements into super expensive disasters. Like hard water leaves mineral deposits, right? That creates sediment buildup in your water heater tank. That sediment literally insulates the water from the heating element, making the unit work harder and harder until, boom, ultimate water heater death. A winter freeze turns standing water into expanding ice, which leads directly to split pipes. And that shifting clay soil we mentioned, it alters the angle of your drain lines, creating these low spots where wastewater just pulls up and blocks the entire system.
Oh, and if you live in a pre-1970s home, you've got an invisible enemy hiding behind your drywall: galvanized steel supply pipes. Because of the water chemistry and just the sheer age of the material, these pipes literally rust from the inside out. They quietly choke off your water pressure, they ruin your water quality with nasty discoloration, and they essentially set a ticking clock for a total system failure that's going to demand a professional rescue.
Which brings us to Section 3, the physics of plumbing.
Plumbers aren't just, connecting tubes together. They're practically engineers managing fluid dynamics. Take the 135-degree rule. You cannot, absolutely cannot, just slap a sharp 90-degree elbow into a horizontal drain. Why? Because a sharp corner creates turbulence. That turbulence traps solid waste, and especially in older cast iron pipes, it guarantees a severe clog down the line. Instead, plumbers use two 45-degree fittings, or a long sweep 90, to create this really smooth, gentle path for gravity to just do its job.
And this brilliantly illustrates the real precision required behind the walls. Plumbers use the 1.414 rule, which is a strict mathematical formula. If they need to route a pipe around an obstacle in some cramped, dark basement crawl space using 45-degree elbows, they don't just guess or eyeball it. They measure the offset distance and multiply it by 1.414 to find the exact pipe travel distance needed. It guarantees the angles line up flawlessly, so the entire system keeps its structural integrity.
That crazy level of precision totally extends to pressure and gravity too. Your water supply lines have to be calibrated to maintain between 40 and 80 psi. Too little pressure? Your fixtures literally won't function. Actually, scratch that. They might trickle, but they're useless. Too much pressure, which is super common with those hilly elevation changes we talked about, and your appliances just get blown out. Meanwhile, drain lines rely entirely on gravity, and building codes demand a very precise slope, exactly 1/4 inch of drop for every single foot of pipe. No more, no less.
So why is that slope so exact? Well, it really comes down to basic household survival. To quote the source material directly here, flat sections create clogs as solids settle. Steep sections cause water to rush ahead of solids, leaving waste behind. I mean, think about it. If that pitch is off by even a fraction, the whole system completely fails.
Section 4. The 3-step rescue. So when water is actively pouring through your living room ceiling, every single second feels like an eternity. The professional response requires this rapid, yet super methodical approach. Step 1, contact and dispatch. No voicemails, just immediate deployment of a fully stocked truck with parts meant specifically for local homes. Okay, take a breath. Step 2, diagnosis and approval. They use cameras and pressure gauges to find the hidden issue, explain the actual physics of why it failed to you, and give you transparent pricing. And finally, step 3, repair and testing. They carefully contain the chaos, fix the geometry, and rigorously test the system before they even think about leaving. It's this calm, totally transparent process that resolves total panic.
But remember, it's not just about fixing the water. It's about following the law. Modifying these intricate physical systems in Allegheny County requires strict permits and inspections based on the International Plumbing Code. And guys, this isn't just bureaucratic red tape. It's a literal safety measure for your home. It protects your health, ensures proper venting of toxic sewer gases, and guarantees your water supply is safe. Skipping these permits just to save a quick buck can leave you completely legally liable. And trust me, it will derail absolutely everything when you eventually try to sell your property.
All right, our final stop. Section 5, Costs and Hidden Dangers.
Let's talk hourly rates. In this area, you can generally expect to pay somewhere between $75 and $150 per hour for standard professional plumbing work. Now, that rate definitely climbs if you're dealing with a midnight emergency dispatch or if the job requires specialized skills, like fixing a gas line or wrestling with those deeply corroded 1950s pipes we looked at earlier.
Next up is the call-out fee, which averages between $50 and $125. This basically covers getting the truck dispatched, the travel time, the professional diagnostic work to figure out exactly what the physics of the problem actually is, and your first 30 minutes on site.
So the crucial point is knowing when to open your wallet and when to open your toolbox. If you're just replacing a simple faucet aerator, absolutely do it yourself and save the cash. But if you're repiping or doing major sewer work, you absolutely need a professional. The tiny bit of money you save on a DIY fix pales in comparison to the thousands of dollars risk of catastrophic water damage, voided manufacturer warranties, or serious code violations. Seriously, unless your idea of a fun weekend is swimming through a flooded basement, leave the heavy lifting to the pros.
Because those risks, they multiply rapidly once the walls are opened up. These are the terrifying hidden costs of local infrastructure. You might think you just have a slow drain, right? But you might actually have to jackhammer through a solid concrete slab to reach a bellied pipe. You might go to shut off the water, only to find the corroded valve completely shatters in your hand. You might need full yard excavation to remove tree roots, or discover your venting is so outdated it needs an entirely new system just to pass modern codes. This is exactly why expert diagnosis, like dropping a high-tech camera into the line, is completely mandatory before any major work begins.
And that brings us to the end of our journey today. We've seen how the environment relentlessly attacks, how precise physics hold it at bay, and how professionals navigate the chaos. So, I want to leave you with this final thought. When the next freeze-thaw cycle hits and that clay soil starts shifting around your home, are you prepared for the hidden world reacting behind your walls? Thank you so much for joining me for this explainer. I really hope you walk away with a newfound respect for the incredible, intricate engineering of your local infrastructure.